All right, let's talk about something really cool today. It's a project that asks a pretty brilliant question. What if you could get all the power and flexibility of the MongoDB API, but you could run it all from a single, simple file? Well, that's exactly what we're diving into with NeoSQLite. If you're a Python dev, I'm sure you've felt this pain. You absolutely love working with documents. You know the PyMongo API like the back of your hand. But you really don't want to spin up a whole MongoDB server just for a quick prototype, a small personal project, or, for running your automated tests. All that configuration, managing the service, it just feels like overkill, right? And this right here, this really just says it all. I mean, look at the left. That's the traditional MongoDB world, with servers and clients and all that complexity. Then look at the right. That's NeoSQLite. It's just your app, the library, and a single little database file. It's just so clean. It swaps all that server ceremony for simple file access. So how did a project like this come to be? Well, it didn't just pop up out of nowhere. NeoSQLite actually started as a fork of another project, and it's been on this really deliberate, careful journey to become what it is today, a seriously impressive, high-fidelity replacement for PyMongo. You can really see the evolution on this timeline. It kicked off with an alpha release, and then right away in version 0.3.0, it added a huge feature, change streams. That's the ability to watch for data changes as they happen in real time, all built on top of native SQLite triggers. Super clever. By version 1.9.2, it was tackling complex aggregations. And then, the big one, version 1.10.0 hit full API compatibility. We're not just talking about a few common functions here. We're talking deep, true compatibility. Yeah, I want to stick with this for a second because this number is everything, 100%. And this isn't just some marketing slogan. As of the latest version, 1.13.7, it passes 360 out of 377 automated tests that run directly against a real MongoDB server. And those few skip tests, they're not because of bugs or missing features, they're just due to the fundamental difference between a file and a server. The bottom line is, the API you already know just works. But getting the API right was really just the beginning. Once they solved the what, the projects shifted focus to the how, as in, how can we make this faster? How can we make it more robust for people who are going to use it for real? The goal became all about performance and adding those essential maintenance features. So, let's talk about performance. Starting with version 1.11.0, they introduced something called SQL translation caching. The very first time you run a complex query, the library does the heavy lifting for you. It translates that Mongo-style query into a really optimized SQL statement that SQLite can understand and execute super fast. But here's the magic. The next time you run a query that has the same shape, maybe you're just searching for a different user ID or something, it doesn't do that whole translation process again. Nope. It just grabs the SQL template it saved in its cache, plugs in your new value, and runs it. The entire translation step is skipped, making things way faster. And the results are pretty staggering. For regular repeated queries, you're looking at a 10 to 30% speed boost. But think about dashboards, API endpoints, or reports, things that run the same exact query structures over and over again. For those use cases, we're talking about a 50 to 60% performance improvement. That is absolutely huge. And it's not just about speed. The project really matured. Version 1.12.0 added some critical maintenance tools, like a safe way to do an auto vacuum. This is so important for long-term use because it reclaims disk space after you delete a bunch of data. It stops your database file from just getting bigger and bigger over time. It's a sign that they're thinking about the long-term health of your data, not just flashy features. Okay, so we've got full compatibility, we've got killer performance, but this next part, this is what takes NeoSQLite from just being a really clever library and puts it into a whole new league. This feature is an absolute game changer. I mean, the project's own tagline says it all, right? So what is NX 27017? It is a MongoDB wire protocol server. That's the fancy way of saying it's a translator that sits on top of your SQLite file and teaches it how to speak fluent MongoDB to the outside world. And this is where your jaw might drop a little. Just look at that code. That's just plain old PyMongo code. There's no special NeoSQLite import anywhere. You connect to localhost 27.17 just like you always do. All you have to do is run the tiny NX 27017 server, point it at your database file, and your existing application just works. No changes. Zero. It's incredible. So how is this even possible? Well, think of the MongoDB wire protocol as a kind of universal language that all the different MongoDB drivers and tools speak. NX 27017 acts like a universal translator. It listens for requests in that language, translates them into actions that NeoSQLite can perform on the database file, and then translates the answers back for your application. Your app has no idea it isn't talking to a real MongoDB server. It's totally seamless.
So that brings us right up to the present day. The very latest releases, like version 1.13.7, are all about adding that final layer of polish. It's about refining this amazing ecosystem, digging into the nitty-gritty details of compatibility, and making sure everything is absolutely rock solid.
You can see this dedication in the latest fixes. The new version added full support for $call stats. Now, that might sound obscure, but it's an aggregation stage that gives you statistics about your collections. This isn't a headline feature, but supporting it shows a real commitment to making even the administrative and diagnostic parts of the MongoDB API work just like you'd expect.
And that incredible wire protocol server is getting the same treatment. Version 0.5.1 fixed the grid FS chunk size. That's how Mongo stores big files, to match the official default. It also beefed up the logging to make debugging easier and just generally improve the code quality. Again, these aren't the flashiest updates, but they are the foundation that makes a tool stable and reliable in the long run.
So, when you look at this whole journey, from a simple idea to this complete, powerful ecosystem, what's the big takeaway here? What does this all mean for you? Let's just sum it up. You get the entire PyMongo API that you already know and love, but completely serverless. You get a super high-performance database, especially for repetitive tasks, thanks to that smart caching. And with NX 27017, you get a zero-code change drop-in replacement for MongoDB that can work with almost any application. It's really the best of both worlds, pure power and dead simple convenience.
And that brings us to the final, really interesting question. With this kind of compatibility, this kind of performance, and this level of seamless integration, it really makes you stop and think. For your next prototype, for your local development setup, for your testing suite, or heck, even for a small or medium-sized production app, do you really need a whole database server? Or could your next big idea run perfectly on just a single file?